Hey y'all, today we're going to take a look at complex numbers. We know about other types of numbers, but we're going to add complex numbers to our knowledge of different types of numbers. So let's start with the first question that we have up here. It says, what could the value of x be in the following equation? If we have x squared equals 25, we would start by taking the square root of both sides because the opposite of squaring something is to take the square root. When we take the square root of both sides, we'd end up with x equals plus or minus 5. So 5 times 5 would give us 25, and negative 5 times negative 5 would give us 25. So that would be the answer to this first equation up here. But let's take a look at what happens down here. What could the value of x be in the following equation? X squared equals negative 25. So I still would take the square root of both sides because that's the opposite of squaring something. So when I take the square root of both sides, I would get this negative that's underneath the square root. So up until this point, we would say that there's no real solution or we would stop. But now we can keep going because I'm going to introduce something to you called an imaginary number. So the imaginary number is represented by I. So I for imaginary. The imaginary number I is defined as the square root of negative 1, where I squared equals negative 1. Now, hopefully this stands out to you because it should be the only number that you know of that when you square it gives you a negative. Any other number when you square is going to give you a positive number. Positive 5 times positive 5 is 25. Negative 5 times negative 5 is 25. So both of those are positive numbers. This is the only number when you square it, you get a negative back. And this one should stand out to you as well because I is a square root of a negative number. Now, my phone is ringing, but we're just going to let it ring, and I'll call them back after the video. All right, so imaginary numbers are not real numbers, but part of a number system called complex numbers. So complex numbers is going to be the overall arching umbrella of all the different types of numbers that we know. So we're going to add this with our rational numbers, integers, whole numbers, irrationals, etc. So we'll add that in today since we'll know about complex numbers. So I've gone out here and I've done a few examples for us. So the first one. Say we have the square root of negative 25. The first thing that we need to do is get rid of the negative underneath the square root. If you have a negative underneath the square root, that represents the square root of negative 1. So that's right up here that I'm circling with my pen. So that represents the square root of negative 1. The square root of negative 1 is I. So you can pull out the I part of the problem. Now the problem is just I square roots of 25. And the square root of 25 is 5. So my answer for this problem is 5i. So the square root of 25 is 5, but the square root of negative 25 is 5i. Next one, I did a very similar thing here, and I did write one additional step in case we needed it there. Let's see if I can pick both of these. Here we go. So what we're really doing is we're taking out the square root of negative 1. So the square root of negative 1 is I. And then you're keeping the number positive because we know how to work with positive numbers. So the square root of 144 is 12, and then you just bring your I down. So the square root of negative 144 is 12i. The last one, we had to do a little bit more work to the last one. I pulled out the I part of the problem. That represents the square root of a negative 1, but 20 can be factored. The other two problems we did, 144 and 25, they were perfect square numbers, so I didn't have to worry about factoring, but I needed to break 20 down. So 20 is 5 and 4, and then 2 and 2. Pairs go on the outside, everything else goes on the inside. So 2 square roots of 5 represents the square root of 20, and then I is my coefficient in the front. So when you're simplifying your square roots, pull out I. So take out the I, take out the I, take out the I. That represents the square root of negative 1. That's the imaginary part of the problem that we're taking out so we can do like we normally do with our problems. All right, complex numbers. The set of all numbers in the form A plus B I. With real numbers A and B and imaginary number I is called the set of complex numbers. So complex numbers have a real part and they have an imaginary part. Up until this point, we've only been solely working with the real part of the problem. But now we're going to be incorporating the imaginary part of the problem into our knowledge. So some examples, I'm going to be writing down lots and lots of examples. One example would be 5 plus 3i. 5 is the real part, I is the imaginary part. Negative 2i. This only has an imaginary part, but I can do the real part if I wrote it as 0 minus 2i, but we don't need to write the 0 there. Another example would be 7. 7 is a pure real number. There's nothing imaginary to it, but I can write it as 7 plus 0i if I needed to. Next, another example would be negative 10 minus I. So negative 10 minus I got a real part of the problem, and I have an imaginary part of the problem. And one more example, 14 plus 8I. I got a real part of the problem, and I have an imaginary part of the problem. So these three numbers here have a real and imaginary section to them. Real, imaginary, real, imaginary, real, imaginary. These two only have one part. This one is a pure imaginary number, and I'm abbreviating pure imaginary, and this one is a pure real number, meaning it doesn't have anything imaginary to it. Now, I could add zeros to both of them, but that's not necessary. So over here, now this is our new set of numbers. So complex numbers are the real big umbrella that everything falls underneath. So underneath a complex number, we can have a real number and we can have imaginary numbers. Imaginary numbers are going to have an I with it. Underneath a real number, you can have a rational number that we talked about a little while ago, or you can have an irrational number. Underneath a rational number, you can have an integer or whole number and natural numbers. So complex numbers are the big subset, and then I could break it down into smaller subsets as we talk about different types of numbers. We're going to end with doing some calculations with imaginary numbers. So we're going to start by adding and subtracting imaginary numbers, and tomorrow we will multiply and divide with our imaginary numbers. So you add and subtract imaginary numbers like you would normal variables. You're going to add and subtract like terms. So looking at my first problem here, we have 5 minus 11i plus 7 plus 4i. We're going to add the real parts of our problem, and we're going to add the imaginary parts of our problem. So we have real, 5 plus 7 is 12. And then we're going to add our imaginary parts together, which are negative 11 and positive 4, which gives me negative 7i. Okay, it is just that simple. 5 plus 7, negative 11i plus 4i. Real plus real, imaginary plus imaginary. Let's try another example down here. So we're going to be adding 7 plus negative 8. That gives me negative 1. And then I'm going to be adding 3i minus 2i. And 3i plus a negative 2i is 1i. So that is our answer. We did real plus real, and then imaginary plus imaginary. Now let's do some subtraction. When we do subtraction, I strongly encourage you to do keep, change, change. So we're going to keep the first one. Okay, I just brought it down, change the plus, and change the sign of everything else. So I did keep, change, change. Now it turns into an addition problem. Negative 5 plus 11 is 6. And I plus 6i is 7i. Okay, one more subtraction problem. We're going to keep, change, change. So I'm going to keep the first one, negative 4 plus 7i. Change to a plus, and change the sign of everything afterwards. So negative 8 plus 2i. Now I'm going to add my like terms together. I'm going to do the real parts of the problem. So that's going to be negative 4 plus negative 8. That's negative 12. And 7i plus 2i is 9i. So when you are adding and subtracting with your complex numbers, real plus real, imaginary plus imaginary. So the real parts will not have an I to them, and the imaginary parts will have an I to them. And just a general rule of thumb, you write the real part of the problem first, and then the imaginary part second. Let's take a look at what to do if we have like some I squares or kind of different kind of multiplication going on here. We're going to do way more multiplication tomorrow. I'm just going to practice using the I squared and how to simplify that. So if we're doing 4i times 5i, we're going to multiply 4 times 5. That's 20. And I times I is I squared. Now, one of our definitions for today, if I scroll up just for a minute, it tells us that I squared equals -1. So hopefully you wrote that in your notes. I squared equals -1. So we're going to make a substitution. I squared equals -1. So I'm going to substitute. I'm going to take out the I squared and replace it with -1. Now I can multiply these. 20 times -1 is -20. And the last problem for this video, I'm going to do -3i times 2i. We're going to multiply our numbers and variables. So -3 times 2 is -6. I times I is I squared. I squared equals -1. Let's make a substitution. And -6 times -1 is 6. So they're not too bad. Hopefully you don't find them too bad. I squared equals -1 and I equals the square root of -1.